Welcome to part 2. C++, here we come. It's fun time. And after the last episode I checked everything. So I've just commented things out here and I've added a couple of lines. So spot the error in matrix 4D. Whoa, what did I do wrong there? Let's have a look. Of these two lines here, please. Selection, edit. There we go. So let's build and run. All we're going to do is look at one bit of the matrix. So here we go. Build. And run that. There we go. Matrix value for row 3, column 0. Well, that's an interesting number. 1. Remember I said was talking about the identity matrix being in a diagonal? Well, column 0, the first column, row 3. No. That should be a 0, surely. Yeah, you're quite right, it is. It's supposed to be a 0. So, let's do that for you. Here we go. Let's have a look at what we did. Source. Matrix. Yep. Copy and paste. It's put the 1 in. Oh dearie me. Let's 0 that lot out. Now this is a header file, isn't it? Header files don't actually compile. So it should be able to pick that up straight from the header file, shall we see? Yeah, let's just do that now. No. Just gonna undo all the rest of it as well. Yeah, let's get everything back in. Selection. Oh, you. Yeah. There we go. Everything's working now. You off there. I want you full. See what's happening now. Run build task. Brilliant. Execute. Ignore that top bit. Executing task. La 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 la. There we go. Terminal will be reused. Thank you. And now let's run it. There you go. It's picked up that we changed it to 0 and we didn't rebuild Amber SL. So, a thing to watch out for. .h files are not compiled. I forgot to mention this. And you can change them and it will pick up your changes without recompiling Amber SL. That's another reason why I wanted the maths in there as that. Just to show you how to cause errors and how to make a mess of things. So, all tested. All looking good. I'm going to keep that bit. Let's get rid of that bit. I'm going to keep that bit for a long time. I'll just separate it. I'm going to keep the bottom bit for a very, very long time, so I'll just separate that. Type in the middle. Here we are. That's all done. And run build task. There we go. Nothing stupid happening in there. Everything's nice and clean, no warnings. Run it. We should be back to a very, very simple argument equals colon. Oh, 1 value equal colon. Yeah, that bit. There we go. I did fix that once, but then I went back, didn't I? Right, so our test area. Yeah, okay. There we go. Any code outside the test area will keep. I'm keeping the top code to stop warnings, and I'm keeping the bottom code just so we have to press a key to close. That's all I'm going to do. There we are. The maths I'm happy with now. I don't want to do any more maths. I want to load our data, don't I? So under source, let's have a new folder. Let's call it models. Why not? And in models, new folder. Let's call this something or other. Oh, decisions. How's about call it model loader or something like that? Yeah, model loaders. Yeah, okay. Model. Capital, won't I? Loaders. There we go. Model loaders. Under model loaders, let's put some files. New file. We'll have an OBJLoader. .h. I'll also have new file. I'll have an OBJ loader.cpp. Oh, I get pretty symbols as well, isn't that nice? Don't need you open anymore, you're fixed. Don't need you open anymore. Save. Then we can close. OBJLoader.cpp, so that's an easy one. Hash include, and that will be OBJLoader.h. Go down to line 5. Here I want my pragma. Now, namespaces. Well, we've decided on our main namespace, haven't we? So namespace is going to be Amber. That's our controlling namespace. Everything has to go in there. Well, I'm going to embed it a little bit further. I'm going to embed this into whatever the directory is called. Model loaders. Model loaders. There we go. How's about that? Now, if your editor doesn't have these lines between things, I would advise you to do something about it. Go to your options and make sure that you've got dotted lines, a line, you've got some way of matching up these, because they are very, very important. I'll show you why. If I put int a here equals 1 or whatever, that will be destroyed when it hits that curly bracer. If I type in here int a equals 1, now the first thing is these two are two totally separate variables. Oops. Yeah. These are two totally separate variables. They are inside different braces. So that is illegal. That is illegal. That is crazy. But this is how you separate variables off. The naming of them using namespaces. But that int a gets destroyed there. Yeah. Very interesting. So when you come out of a curly brace, you got to be careful. I might use a again, thinking it's still this one. When it isn't, it's this one. So put a bit of thought into things and you will save yourselves a lot of trouble. Namespaces are to protect our code from the standard library, and also to protect standard library from us messing about. We're going to do nicely. Okay, let's program this. So What do we know? Not a lot. I know that I'm going to need the data. I'm going to read it from the disk. What data do we have? Let's have a look under test. I'll use the head. Look at all this lovely, thank you, data. We've got vertices. We've got texture coordinates. We've got normals. None of this means anything to us. And we have faces. Ah, faces. Yes, that's what we want. We want all these faces here. But what do these numbers mean, Blades? Well, I'll answer that for you. These numbers refer back to the position in the file of this data for your vertices and your textures and your normals. And stuff like that. So I'll go more into that, but we're going to be using this data, translate this data into something that we can use. And luckily a .obj file is just a text file. So reading it in is going to be easy. All we've got to do is ignore all the rubbish at the top. So in the header file, we're going to need data. Again, I'm going to use structures to store data. So data structures. Let's have some of those. Anything else we might need? A class, that might be helpful. Yeah, we'll have one of those. We'll have a model loader class. Anything else we might need? Headers. Choices. What we got here then? Yeah, we're going to need quite a bit really. We're going to need some way storing all of these structures as we read them. So store data into structures as we read them, and find out what the data refers to, because we won't know at that stage. I'll describe it as we go, don't worry. Clean up after ourselves, yeah, we can do that. There we go, I'm writing a program. Oh look, I'm writing in English. Oh dear. Isn't that a language? Yeah, it is. Yeah, so that's a program. Let's have a look. I think it's going to be best to look at our structures, because that's what it all hinges on really, those data structures. So that's going to be the main focus of today, I think. Getting some structures. So vertexes and normals. What do we mean by vertexes and normals? Let's have a look. Where is it? Oh, it's down here, isn't it? Ahead. Vertexes. These are these numbers here. These are the dots, positions in space for each dot. If you join the dots, you get triangles. If you use them in phase 1, phase 2, phase 3, you might have noticed that last number's always the same. Phase 4, phase 5, phase 6. If you use the correct 2, 4, 1 vertex, you will get 2, 0, 1, no it isn't on here, is it? It's 1, 2, 4. So you go 2, 4, 1. If you join lines between those three, you'll get a triangle, and that will be a face. The normal to that face will be the first one. will be that one there. And that's how the data is structured. All of these texture coordinates are just per face, I think. I'm not sure which one are they. I can never remember if this means that's the first normal. Oh gosh, I've got it all up in my head again. Let's write it down so it can unmix it from my head. Otherwise I'm just going to be a gibbering idiot for the rest of the day. Oh, nothing abnormal there. So, let's start with our first structure. And we are going to have vertexes, which are positions of the dots. Is it vertexes or vertices? Vertices, isn't it? Vertices and normals we'll have. Why not? And they're going to be vectors, aren't they? So vex 3. Yeah, okay. We know how to do that already. We've done it before. So struct. How's about coordinate? There's a good name, because I can. Yeah, we'll put some braces on. Oh, you... Ouch, I hate it doing that. Don't you dare do that to me. Hate that style. You'll see it a lot. The people program that way. Eesh, no thanks. I need to be able to match my braces. I don't mean the ones on brown with teeth. So, position. Well, we already know what positions look like. It's an X, Y, and a Z. There we go, we have 3 floats, X, Y, Z. I could have put them on 3 lines. No, can't be bothered, I'll put commas in instead. Yeah, I'm guessing that's all there is to it. So it's basically our Vec 3. Or very simplified, well, it isn't our Vec. It actually. So we could use Vec 3 here, but I want to be able to manage this in a way that describes what we're doing. So we'll call it coordinates. It's duplication of effort, so what? It's all the same. You can see it's all the same. Differences is that I'm not putting values in. And I'm also not going to put a colon at the end and assign all the values and all the rest of it. I'm just going to make it into a standard struct because we're in a header file. A real header file this time. And go on. So we've got a coordinate, float A, float B, float C. We've got X, Y, Z. Yeah, that looks good. If we get rid of that last squiggly, I'll be happy. Thank you. That's it. Done. Yeah, that was difficult, wasn't it? Right. Next, what do we want? Alright, I've been talking about faces of those triangles, and it's the faces that actually matter. So, let's make one. Let's make a face. So, a face structure. Very complicated idea. What do we need? Well, we'll take an integer and we will call this face num. The number of the face. 1, 2, 3, 4, 5, 6, 7, whichever face it is. So it's going to start from 1, not 0. So if you do want to use it as an index, calculations on a computer start from 0. A .obj file starts from 1. Why? Because the person who originated the .obj value didn't realise that computers started from 0. It's as simple as that. So the format's wrong. Basically. I just said basically again, haven't I? Oh dear. Ow! Yep, I did hit myself. Sorry. So yeah, face num. We'll have that. If you want to put a note in, we will. This is something else that I really hate. people having to do this. The number of the face. Oh, come on, guys. It's called face num. Do you want me to call it num face? What? Okay. Let's call it num of face. So that means we don't need that anymore. There you go. If you have to start notating your files so that you know what a variable is, then you're doing something wrong. If you don't know what the variable is, then make the variable name something that's real. And you can. So we'll have that as number of face. There you go. Now, when we were doing our models, I glossed over quads. And there could be 4 points or vertices to a quad. But I said put it into triangles to make it easier. We still have to allow... Oh god, that's not a word. We still have to allow for quads, and I do want to program those in. A quad is 4 vertices. 4 vertices per face. I could put per face if you wish. Not going to. I don't know what it means. And that can either be true or false. If it's true, then it's a quad. If it's false, it's a triangle. There's only 2 things it can be, so it's a bool. A bool means true or false. Boolean logic, that comes under. So there's something to Google. Wow, I'm going to do some Boolean logic. Ooh. No, the computer's going to do some Boolean logic. We are not. So, the maximum number of faces that we can have is... Oh, sorry, points in a face is 4. There we go. So we'll put that in. Put ints. Because it's an index. Yeah, okay. It's an index of faces. For a face, should I say. So face 1 will have 4 points. Up to 4 points. It will also have up to 4 texture coordinates. So I'll call that text. Coords. Well, we could have 4 of those. This is just going to create an index, a face structure. Okay, yeah, we might have a material. I don't know. A masterial. Oh, wow, I'd prefer that name. But material will do. If material is colour, texture, colour, whatever. Playing around with colours, playing around with textures. At the end of the day, I want to be able to use straight colours or textures. At the moment, I'm just going to go for textures, I think. I've got all my semicolons in because I'm still getting a red squiggly here. I haven't got anything wrong. Interesting. Oh, right, it doesn't know what we're doing, does it? Right, okay, fair enough. So, the index of the material which is used by the face. We'll just call that material, whatever you want to call it. Now, because I've put that boolean in, it means that we have to declare it twice. Sounds stupid, doesn't it? But it isn't when you think about it. So we are going to take our information into this structure using a face number. I'll put it in here. There's the next thing we wanted. F faces, so F1, comma, in face 2, int face 3. That'll do a triangle. 3 points make a triangle. Yeah. Then we'll need the textures, so ints again. Int t1 texture. Do this thingy again, won't I? Yeah, there we go. Loads of space. Int texture 2. Yeah, it's a bit long-winded. Int texture 3. Did we need anything else here? Oh, we need that material, don't we? So int m. There you go. And we'll use a semicolon at the end, not a colon, because we're not defining it here. So we've got our triangular face. That'll construct us a structure of indexes or a face, because we're going to have to index everything. So it's just so that we can manipulate it into whatever we want. At this point I do need a drink. A bit of Coke. It'll probably make me burpy all over the place like. That's Coke. So that's what a triangle will look like. But I have said that we will accept quads at some time. So it's... Watch me make copy and paste. Should never ever copy and paste. But I just done it so there. So there will be a int for... It has made me burpy. And int t4. That's the only difference for a quad. Does that look right? Face num 1, 2, 3, 4, t 1, 2, 3, 4, and material hanging on the end. Importantly, a semicolon and a burp. There we go. That's a structure for indexing the face. And I still have this squiggly. I expected a semicolon somewhere. What? What semicolon? Where? Oh god. Semicolons, people. Semicolons. All the time. It's C++. So after a structure declaration, at the end of it we need a semicolon. No, come on. Come on, come on, come on, come on. Save it out. Yeah? No? Yeah? Okay, I can't see any semicolons not done. Expected a declaration now. That is a declaration face. No definition here. Just declaring that face is going to be using those numbers. Okay, you go be happy with yourself somewhere else, IntelliSense. I've got to get on with this because we want to get through this video today, don't we? Right. Materials. We've just spoken a little bit about the materials, so we may as well do a material structure. Material data. This will be a struct. Oh. Good point. That's what's wrong with it. Struct. What was I calling this one? Faces? There we go. FACE, FACE, yeah, that matches. And I missed a comma. Good old copy and paste. Love it. Okay, all errors gone. Yeah, all errors gone. Nice. Yeah, I think we've done that now. Pop that down the bottom so I can see it. Alright, so we're okay there now. Yeah, that's what it's talking about now. Materials, that's where I was up to before I got distracted by red squigglies. Hooray, I remembered me semicolon. What do we want for a material? We'll have a name. Name is a string of characters. So we're going to need strings, aren't we? Strings for my guitar. Hash include STRI string or string H. I'll have string. Why not? I think that's right. Yeah, I'll have string. Standard library. So std : string is now available to us. That's how header files are used, folks. Header files just contain functions that are pre-written for us. In this case, it's a string function. I'm going to call this one name. Now it doesn't like std. Come on, catch up with me. I'm just going to call it name, that for the name of the material. Simple as that. Nothing interesting. So, some properties. Stuff that we don't really want, I suppose. We will go with that A channel. If you can remember when we were doing textures, I said RGBA, alpha channel. We might use that for transparency. NS, that comes in there. NI. I'll show you where those have come from. Head, body. I think it's down the bottom, is it? Hasn't got them in here. We've got an S. No, it's not on that one. You can get them mixed in some places. It all depends on the materials that were stored with stuff. Oh god, this is massive. Drag. The N, yeah. I'm not typing these in. Used material none. S off. You too. What do you think? No, they are in some. These are things that can happen to appear within .obj files. So alpha channels, NS, shininess, I suppose is the best way of putting it. NI, dunno, indifferent. That's the letters it gives in the file. That's the letters I'm just going to put there. It's as simple as that. We are going to have 3 things that we do want, like colour. So let's have a float. Let's have a diffused colour. So diffuse. Double F. Yeah, why not? There'll be 3 numbers for that, an RGB, red, green and blue. Ambient, the low level lighting that keeps things around you alight, and so you can see. Diffuse is direct light. We want 3 of these as well, don't we? Specular, shininess again, how the shyness speculates. La 3. Yeah, I'll do that. There's your colours. You will sometimes find this in the files. Well, illumination. I think that's self-illumination. I think that really means how much light does this object give out. Think neon lights if you want to try and build a neon light or something like that. A lampshade would shed light out rather than the bulb inside it. It's an optical illusion of the lamp being on. Bits and pieces like that. Things can be twisted slightly and illusions created. Texture. So using a texture, we'll have one of those. That will be an identity. If there is no texture, then it will equal -1. Simple as that. That's what we're going to do. And we are going to declare it all now. Great. So we have a material called material. We have a const. Why am I using a char star? I don't know. Doesn't matter. NA. It's just easier because we are going to be using C and C++ to do this. Just makes everything simpler. You won't notice a change in language. You won't even know it's there half the time. But we do slide over boundaries on a language at times. So float alpha. We'll have that. Float n. Why not? Float n2, n1, n2, ni. N2, come on. Doesn't really matter what we call these. Float. Yes. These threes in here. These make these into something which in computer languages we call an array. Now in C++, the name that we give to that array is actually a pointer. So on this part we will have to change it into a pointer. And in C++ you denote a pointer as an asterisk. So the first one's going to be diffuse. So just something to be wary of there. You're learning things today about computer programming. These are the language basics, I must admit. It's how it all works. Asterisk S. Keep it all consistent. I'm just taking basically the first letter. And T, is it for texture? Yeah, texture. There you go. Oh, lovely. I think I deserve a drink after that. Got semicolon. I think we're done with that. Yeah, that'll do. Are you going to go away? You need expected a semicolon. I got all my semicolons. Thank you for going away. Right, do we need anything else? Nah, had enough now. Oh, bless. Oh, spacer. I'll use that as a spacer. There we go. I'm just trying to space it out so you know that those are just structures. Those are the structures that we'll probably be utilizing to manipulate the data rather than store it, because we're going to just take the data in and flush it through a couple, well, a temporary, we'll call it a buffer. I don't know a better name for it. I'm going to flush it through some temporary buffers straight into what we want it to be, and we'll use all of these wonderfully magical structures to do it. How's that then? Let's have some Coke. So, 40 minutes, so we're coming towards the end of this lesson. May as well introduce the class. Our first class. Wow, we've done all this without anything, without even a class. OBJLoader. There we go. OBJLoader class. Da 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 da. Ding. Looks exactly like a struct, except in between here everything is private, whereas all of this is public, so we can access everything. We can access material.float wherever we want. Here, if I type anything, you can't do OBJLoader dot whatever it is because it's private. You can't access it. That's why classes are used, because what you want to do is do all your calculations in private and then make public the results. Make sense? Right, so you get your data in, you do your calculation in private, and then you publicize the results. There you go, the 3 steps of programming, and those are the only 3 steps of programming there ever is. There is data in, crunch your data, do what you want with it, data out. Data out to screen eventually for us. At the moment we're going to take data in from the disk and we are going to mash it about a little bit, and then we are going to present that data to our API, which we haven't written. And actually after this is completed, we can actually jump over to the API and program it. In fact, I will be doing, I think. I'll do that as the next video after we've finished OBJLoader. So we've got an OBJLoader. We'll leave the private area. In public, we are going to offer a constructor. So public, thank you. Yeah, OBJ. This is sort of a standard way of doing things, but hey ho. And a destructor, so we can destroy the object after we've used it. Slightly different way of doing things than a struct, because a struct I use as a straightforward thing, whereas as a class I will do a lot more complicated things. Here we need to make, I'm going to call it void at the moment, don't worry about it, we will change that. We will load OBJ model. It will take in constant std : string. We want the address of that string, and that will be the file name. And we will need to know from our API a loader of some kind. An API, some way of loading objects into OpenGL. I'll leave that off for now. It's alright, we come back and we alter it, don't worry. That's constructed. So we'll go back to private. Yeah, I can put this one in, this is okay. Void clean. We do our cleanup. So what have we got? Store data into structures as we read them. Find out what the data refers to. Cleanup we've done. So cut. Paste. These two. Cut. Paste. Back that up slightly. And there we go. Lovely. That's our class. And there we go, we've programmed it. That is our declarations done. Anything else we might need? Nah. Okay. Just to tidy up these. There we go. Make sure everything lines up. Public, private. I haven't filled in this bit. I'm leaving that. That's going to have a lot of different variables added to it. I'm going to be adding all the private variables in here. Right. Type that in. Private variables. Go here. There you go. Simple. Yeah, I do write a lot of my programs in English. Texture illum. Oh, yeah, that's all gobbledygook. That's turned out very gobbledygooky. Number of faces. Plural. Number of the face. But it's singular. 4 vertices. Faces. Texture. Yeah. Material is singular. Yeah. That's it. Have it all. Save. Can't build it. We have nothing in here. So there we go. So next episode we will put the nothing in here to work. This is where all the work gets done. So this is just declaring everything to our lovely computer to say, hey guys, this is what we're gonna do. Yep, that's how it's done. There we go. In case somebody wants to read it more, that's the class. Massive, isn't it? It's so big and bloated and overgrown, but that's all we're going to do. That, by the way, is a very standard looking class. In fact, it couldn't be more standard than that. You've got a constructor, your destructor, your let's crunch data, and your cleanup. There you go, that's it. The only thing that we haven't got at this point is this, which will be the output. I put it as void at the moment because we don't know what the loader is for the OpenGL. We haven't written it, so if we haven't written it, we can't really define it, but we will before we get there. We'll define it, we'll know what it'll look like, and then we'll change this and we'll give it all the names and stuff, and then we'll go and write it. Simple as that. So well done. Lots and lots of programming done. Yeah, that looks right to me. Very simple, one include. Yeah. Okay. There we go. Right, so we'll take a break, grab a coffee, grab some to eat, and then we will head onwards into the world of OBJLoader.cpp. Might be 2 more episodes, but if I can get it all done in one, just using triangles, I'll do it that way. I might decide to double up and do quads at the same time, or put the things in there so that we can use quads later if we want to. Not sure, but it's got to be flexible. It's got to be flexible at the same time as doing its job. Excellent, I'm happy. Let's continue to the next episode. You people take care, and above all, have fun.